Okay. So, last three presentations are going to start. Thank you very much for keeping up. And then we are talking about things about types. So we keep that for the last leg. So, O'Neill, floor is yours.
Thank you, Mohammed, and thank you, everyone. It's the challenge of speaking in the last segment of the conference, looking at the positives. You get the opportunity to listen to all the talks and try and make linkage to the things that are important and see where it all fits in. So I had a lot of time to think about that. But just to start, does anybody know this bridge, where, you know, the name of it, where it is? No? Yeah, so yeah, that's the Glienicke Brücke Bridge, if I say it right, forgive me. Yeah, thank you. So it marks the border between Berlin and Brandenburg. So as you can see, this talk is all about bridging between XDM types and native type systems. And just a bit of history, it was the bridge in the Cold War was the border between West Berlin and the East. For those who don't know who I am, I'm O'Neill Delpratt. I work for Saxonica. This paper I've co-authored with Matt Patterson. So dealing with XDM through an API rather than directly in XPath, XLT, or XQuery means wrangling different type systems. As you can think of it as writing a program in Haskell using only Java as one example. Saxonica are the developers of Saxon, the XLT and XQuery 3.0 processor. You can add to that schema processor as well. We also are the developers of Saxon C, and I'm going to talk more about that as we go through, which implements all of that in a library accessible directly from C, C++, PHP, and Python. This talk is loosely halved into where we talk about designing APIs that work, looking at issues around APIs that make possible and even enjoyable to work with XDM from a different language. And the second part would be digging deep into the implementation details and the technical issues and issues that we have to contend with to make it all work. So to start, I have to thank Matt here for sending in his part as a video, so I'm going to play that now. All right, no audio, that's not a good start. Can it work?
Connected the audio jack.
Okay, let's go back a step. It's plugged in.
Yeah, but maybe in your laptop you need to say that it should use audio for jack for audio,
Okay,
not the HDMI.
Let's do this again.
Let's start by looking at
Okay, good, thank you.
Let's start by looking at the issue from a higher level. So what do I mean when I talk about type systems, and what do I mean by this gap between them? Just for the sake of simplification and speed, we can consider a type system to just be the way that various core objects of a programming language are structured and interact with each other. We can talk about concepts like inheritance, and we can talk about the idea of primitive objects, primitive values. And what do I mean by primitive values, primitive types? We mean things that can't be broken down any further, like an integer or the object class in Java. When we talk about inheritance, we're usually talking in the context of object-oriented programming. We're talking about objects that are built upon one another, and objects that are built upon another object gaining the functionality of that first object. So here we can look at a very simple diagram of some classes in a type hierarchy with object at the bottom node, and string both inheriting from object. Obviously, an interesting wrinkle here is that we might consider in many places string to be a primitive type, but in Java it inherits from object. The obvious difference with XDM, which we can see here, is that the most primitive object, the most primitive type, the one that all other types inherit traits of in XDM is value, the sequence, which is a collection. This is a kind of inversion of what we might normally expect from a type hierarchy. And while it absolutely makes sense in the context of XML processing and the manipulation of objects in XDM in an XPath-like language, it makes their manipulation and especially mapping them to native types, that's the types in another language like Java or C, more complicated. With apologies to Matt Neuberg, who coined the phrase the English likeness monster to describe the idiosyncrasies of AppleScript and the way that its syntax work and don't work, we can think of the pervasiveness of sequences as pulling the constituents of XDM further away from the standard or conventional objects we would expect in, say, C++ or Python. Values, sequences, are the simplest type. But all atomic values, so strings or integers or whatever, are also one-item sequences. This is very different from anything in pretty much any other language. Now let's talk about string values in XDM in comparison with other languages. We can say some things about strings in XDM. All these statements are true or kind of true. That the length of the XDM atomic value representing the string hello world is 11 characters in hello world. That the length of the XDM atomic value representing the string hello world is 1, because there's one item in that sequence. But also that the length of the XDM atomic value representing a string that contains an enormous number of characters is also 1. Obviously this is kind of facetious, but I hope it illustrates the point. But the functional nature of XPath makes the oddness of XDM go away. We can't invoke the square brackets operator as a method of a map or as a string. We have to use the inbuilt functions to do that. So there's an inbuilt and natural disambiguation that makes a lot of those complexities not relevant for us. Map get is very different to square brackets operator, which can be used in other languages in many places to do many things. We're going to look at numbers just briefly, because converting between different kinds of number types can be a difficult problem. Here are the various XDM number types showing how they're derived from each other. There are quite a lot of them. And here are all the JavaScript number types. Hilarity ensues. This is enormously problematic for number conversions in JavaScript because there is only one kind and it's a floating point. I mean, it's enough of a problem in JavaScript as it stands, let alone interfacing with XDM. But I want to move on. We do need to take a closer look at maps in XDM. Consider a simple XDM map. We get the value corresponding to the key A using mapget, as you can see here. Of course, we can also call the map to get the value because a map item in XDM is also a function item, so it's callable. But obviously it's also a value, so we can index into the sequence represented by the value to get the value out, which is slightly confusing. Compare this with a Python dictionary, which is the Python data structure closest to a map. if we try and index into it as we would if it were a sequence in XDM, we can't. It just explodes because it doesn't have numeric indices. It's just got keys, and 1 is not a key of that map. What do we need to be able to do in order to provide idiomatic local language API access to maps? Well, we need implicit and/or explicit conversion between XDM and native objects, direct mapping between types where that's appropriate, and well-documented rules for widening and narrowing type conversions like those with numbers. But that leads us to another question. Whose idiom is it anyway? Aspects of XDM make the most sense in XPath using the idioms of XPath. But the languages of our APIs have their own idioms. And those are not, as we have seen, exactly shared with XPaths. So we have a couple of things going on. We can talk about competing conventions. What do you choose to represent a certain kind of access to a value in a native language when the obvious choice makes sense for several aspects of that, like square brackets with indexing into sequences and fetching values from maps, or even slicing a string and getting substrings out. Another interesting thing we could look at is whether we can use the context we're operating in to just be ignorant of certain aspects, to basically to ignore some things that make our lives difficult in the native languages that we don't really need. Because maybe it's okay to ignore some of the XDM aspects that make no sense in the context in which we're operating, the context of manipulating a value in Python or in C++. Why should atomic values be sequence-like in Python? It doesn't make much sense. Maybe we can just allow them to not be sequence-like in our APIs. Those are the kinds of questions we're having to deal with, and those are the kinds of issues we wanted to discuss briefly before O'Neill comes back to talk about some of the more technical implementation issues we've been dealing with working across multiple languages and multiple type systems.
Right, so as I said, we're linking between what's been spoken before. I mean, Mike yesterday gave us an insight of the 4.0 specs. It was interesting to see navigating JSON documents and the operation to do that. So it's something that's fundamental, and it's always going to be there. No matter how, from the early days, even now, we have to navigate documents. In XPath, it's powerful, simple, concise, succinct. / person can get you all the persons in a document. You can do more clever things, filter and navigate back up the tree quite easily. But when you now start to build APIs, you've got to think about the structure of that tree. Think of these nodes as objects and how you represent that in memory and things like that. And if you consider now how you would do that in an API, this example here is in Saxon C++ code, to be specific, given you have a node object for this exact same parsed trees that we have. We can get all the children. You can iterate according to a certain axis. We just want to interest in the root axis here. We get the first child and then try and go through all the child nodes. And you can do a lot of things, but why? Already you see that this is verbose, this is error-prone, but at the same time it's giving us the power to do useful things, to connect to multiple systems. But as a C++ programmer, you have to manage the memory, delete things after you finish with it, that sort of thing is the memory management is for the user to take care of. Some more code examples. Think here, think of an XML document which has a lot of package elements, and we want to select all the packages that have an attribute with role equals secondary. In Java, you can use the stream API, Saxon, and it's quite elegant already. You can use stream API to get all the package elements according to the attribute with role equals secondary. Even in Python, you can do similar thing here as well. So already the APIs are trying to make it easier for the user. The focus here is more about Saxon C and dealing with some of these issues in a multi-tier system. Saxon C is exactly that, because it's built upon the Saxon Java product, using GraalVM to cross-compile it to a native library. GraalVM is a JVM implementation that provides the ability to compile the Java code right down to its native representation. It comes packed with everything that you would need to execute the application. But also you can use it as a library to connect to other languages like C++. So the core languages are Java, C++, back and forth. And we provide extensions to Python using Cython and PHP as well. Just to mention, actually, how we use GraalVM to do this, GraalVM has some nice APIs to allow you to expose the Java methods as entry point annotations. You just have to mark it with annotation to say, I want this method to be exposed to the C++. And it provides you with that. These methods are now exported in the native library. But there are problems that we have to address. As I said, it's a multi-tier programming language. The Java garbage collection can get in the way. If you're in the C++ world, as we saw in that example, who knows when the garbage collection is going to be triggered? We have to prevent that from taking away objects that we're actually using. We're now in a C++ unmanaged code, communicate with managed code. And on top of that, we have extensions in PHP and Python, which is, again, managed code. So it can get tricky. Firstly, to address the garbage collection in Java issue, GraalVM API provides us with an object handle. So it's a representation which allows us to, what can I say, take that Java object and provide it into the unmanaged code, C++. It also provides us with an object handlers pool, which is just a set. So within the Java world, any object that we put into this pool, it stops it from being garbage collected. But as implementers, it's our responsibility to remove it from the pool so that if we're no longer using that object, it can be garbage collected as necessary. So this is just a structure of what's going on. So we have some layers. The application layer as a user, we want to write code in C++ or PHP or Python. We communicate directly with the extensions or with the underlying C++, Saxon C, C++ API. There is a thin GraalVM C API layer, as I mentioned before. And within the Java space, you've got the object handlers pool and the Saxon core code base as well. So any object in the object handlers pool won't be garbage collected. So that addresses one problem. But what about the garbage collection happening in PHP and Python? And this is where it gets complicated. So consider this code. I think it's Python code here. So we pass an XML document, which is node underscore, and we pass that to a processor, executable, with the context being a node underscore, and there is some output which is a value as well. And at the same time, we want to do something after that where we set this node object as a parameter to the executable. What happens to node underscore at this point? So Python being Python, it says, well, there's no references at this point, at this point. This node object's not used, so garbage collect it. But we're using it as a parameter within our processor. So that will cause problems. So when we now further down in the code or in some other part of the code want to use that parameter in some other transformation, it's not available. And that causes problems. It will crash. Look at another, so just to mention actually, the assignment prevents this garbage collection from being triggered even from line 2. Because it says, oh, this node has been used. But what happens if you're not assigning this data? So in this example here, it feels like this mic is chipping in and out, but I'll continue. We're making an array object, and within that, we are adding values to that array. There's nothing being assigned. So on line 3, the behavior is undefined. Garbage collection may trigger it and then crash because this object's not needed anymore. That's what it thinks. I'll try and be quick here. So how do we overcome this problem? We have to do our own memory management. And just as Python and PHP is doing, we use our own reference counting of the objects. We can get a bit clever about it and cache child nodes as well, but even that can be complicated because how do I know that this node, this child node has been passed on to the user? Whose responsibility is it at that point? So we have to sort of track access to these child nodes, XDM items and things, and it can get very complicated. So looking at this example, I've sort of combined it here. So we pass the XML document. That node underscore has a reference count 1. It's been passed into an XLT style sheet, and we know that it's within that operation line 2 that the ref count can be decremented. The output's got reference count 1. So right at the end, the node will have a ref count. So we sort of trick Python to say, okay, we're using this object still. So don't try and garbage collect it. And just to conclude, we've opened up and made it possible to cross that bridge. The XDM view of the world is different to the way that most host languages structure data. XDM wrappers that bridge between the worlds need to be a first-class part of the API. I call these first-class citizens. It just can't be an afterthought. You have to think right up. How are we going to communicate between these multi-tier systems? It can be difficult, but we want to do more than just one-shot transformations. And that's what we started with Saxon C. It was like libxml. You just do one shot, and then but you want to do something more sophisticated. Looking back at the history, and it's nice to be able to lean upon what Mike thought of many years ago with dealing with this sort of problem. It's not quite gone away, but it's become more complicated. Because we're wrangling with expectations of managed code in core Java runtime and the managed code in the host language runtime. It is complicated. We still have a lot of room to improve, and we hope this survey, at least at the higher level challenges, I haven't gone too deep, is been useful to other implementers as well as to us as well. Thank you. Any questions?
Thank you.
O'Neill, thank you. I'm asking a question out of utter ignorance of someone who never deals with this low a level of programming. I gave up on memory management as an undergraduate. as something I never wanted to have to do again. How much of a hit is a modern, typical XSLT or X-query processor taking if you took the drastic approach of simply saying, no garbage collection? We're going to let memory just pile up, and luckily, everybody's laptop has 8 gig nowadays, or 16, or whatever it is. I hear lots of no, no, no. That's not going to work, right? That's not a viable solution, is it?
No, it's not going to work, because in the C++ world, then there is no garbage collection, but you are working with a system it's in Java, so you have the garbage collection there. And then you're trying to support people in other languages which have garbage collection. So yeah, it would be nice not to deal with it, but we're not in that ideal world. I've got Matt as well to answer questions. So yeah, sorry.
Thank you for your presentation. You show on one slide some kind of this pool of references. Is it some new API of GraalVM, or is it just the JNI create global reference?
Sorry, can you say it one more time? I think I understand, but let's say it one more time. Sorry.
On one of your slides, you have this pool of references.
Yes.
Where you talk to not to not garbage collect the object. Is it something new in GraalVM, or it's just the old JNI API create global reference?
It's in GraalVM.
Okay, thank you.
So it's just available to you. So it's just object handle and the object handles pool. Or it's a set really, but I just call it the pool.
So maybe one quick question? No? Thank you very much.
Thank you.
And thank you, Matt.